So when we're asked to find the position and the velocity given acceleration and initial velocity and initial position, all we need to do is antiderive the equations we are given. So a of t, that is the derivative of velocity. So that means velocity is the antiderivative of that. So I antiderive each of those. The derivative of sine is cosine. So that means this is sine t. The derivative of cosine is minus sine. So that means this is minus 3 cosine t, because when I derive cosine, I get minus sine. The minus cancels with this, and I get this back. Always add some constant c vector at the end, and that's where the initial velocity starts to be useful. We're told the initial velocity is u0 v0 equal to 0, 4. So that means v of 0 equal to 0, 4. So if you plug in 0 on the previous equation, you'll get sine of 0 is 0, cosine of 0 is 1, plus c, that is 0, 4. So that means c is 0, 4 minus this vector. So that is 0, 4 minus 3 is 4 plus 3, which is 7. So we find that c is 0, 7. So v is putting the c back into this formula, adding component-wise, I'll get sine t, minus 3 cosine t plus 7. So that is the velocity. The position is further anti-deriving this. So s, or in this case we're using r of t, is the antiderivative of v, because r prime is the velocity. So we're anti-deriving that. The derivative of cosine is minus sine, so this means this is minus cosine. And then follow it the same way with a plus c again. And this is not the same as the c we used before. If you want, you can label it c1 and c2. But just for simplicity, I'll use that. At t equals 0, we're told the position is x0, y0, which is 5, 0. So that is, it's telling you 5, 0 equals 2, or equals, when t equals 0, minus 1, 0, c. So subtracting that, I get that the c constant vector is 6, 0, so that is a 6. So that means r of t, bringing it back to this formula there, I'll get r of t equal to, and adding the x component, minus cosine t plus 6, minus 3 sine t plus nothing. So just plus 7t. So that will be the position function, or the position vector for positive t.